So my name is Eric Wright. I'm the technology evangelist for Turbonomic. And Mor?
Mor, I'm a product manager for Turbonomic. I lead our cloud development.
We're going to take a look now. We talked a little bit previous to this in the last video segment about the idea of how it works, what the supply chain is, what the value is in being able to do this in a real-time system. Now we're going to take a look at how it connects. And this is probably, while it's not as enticing a story sometimes, it's what we need to know to make sure. And Jason, you brought up a great question of how do you connect? This is kind of the greatest place to start with that.
So again, all different layers of the stack, and we integrate with different technologies on all of them. So easiest place to start is hypervisor, most basic. So Hyper-V, Rev, Zen, Power VM, and of course vCenter, right? Let's take a look at the most common example. All you need to do is plug in the IP address of your vCenter and then user credentials, and within a few minutes can start gathering data. And it's as simple for other hypervisors. We can talk about storages. Again, another very common integration for us. We integrate with a good number of storages, constantly adding more. Let's take a look at application servers. These are the application servers we support today. And Jason, you asked before if it's agent-based. No, all you need to give us is the address of the services, the port they're running on, and credentials to access their API. And that's true for all applications. Then from a network perspective, we integrate with flow collectors, right? NetFlow or SFlow, or with the Arista switches. And then Windows applications, we support Exchange. And under Fabric, OneView, UCS, and UCSC.
It was a conscious decision to make sure that we went at it agentless, because while there's more data you could probably gather and more instrumentation you can get through an agent, there's friction in that process, and we wanted to make sure that we're completely abstracted away from that and we're completely frictionless as we drop into the environment. And as Tim had asked, how does it go in? It goes in and it's basically, in sort of a read-only type of mode. So it goes in there, we're collecting instrumentation, we provide decisions that you can make and actions you can take, and then it's up to you to be able to take that action from there or automate it. Same thing as drop us in the environment, no agents to deploy, so this way we're live and working immediately, and even the long term, we're not a problem now, because what if the agent goes down? What if it's on CentOS versus this, and next you got Photon, and we know the story. So that's, while it seems like there's a little more data we could gather, our attack vector on that is that we added APM in there, so we can actually plug in with, if you've got Datadog or AppDynamics, or you've
that
got
was my question,
Dynatrace.
Right? You take a look at the acquisition of AppD, big acquisition of AppD, right?
Yeah.
That has to cause some discussion amongst your team, and that what we're seeing is customers want to go to more of a fluid or dynamic PaaS model or cloud-first delivery model, whereas I think this still has that feel of an infrastructure monitoring and enablement tool. And I was curious to hear kind of what your thoughts, where you guys are going on that, what you're thinking about that, kind of as we shift and applications get redeployed and changed, and where you would want to go to kind of be in that AppD, New Relic, Datadog type space.
So I think one more point on what Eric made previously is that it's true that we're not delivering agents because it's easier, faster, less friction, but also because we don't think that the more metrics we collect, the better we are. Our goal is to deliver application performance as efficiently as possible. Collecting more and more and more metrics that we can't control is not what we're trying to do. Again, monitoring is more of a byproduct. And then for your question, we can start talking about what it is that we do for cloud, cloud native, cloud OS. Again, we support Kubernetes and Mesos. We support PaaS, and we can integrate with APM tools in different ways. And we're constantly looking at how do we go up the stack, and improve what it is that we have above that layer as we extend what we do for infrastructure. The reality is that everywhere, doesn't matter if you're using containers, container pods, applications running on bare metal, there's always demand coming in from an application, right? More users clicking here versus more users clicking there versus everyone went to sleep versus it's Black Friday, right? And it constantly changes. And you're always going to need CPU, you're always going to need memory, you're always going to need resources to run code, right? Whatever it is, you could call it infrastructure as code or, whatever cloud providers come up with next. It's always going to be there's demand and something needs to drive the supply. And if these two things don't match, doesn't matter where you're running. These two things are not aligned. If supply doesn't match demand or demand doesn't match supply, you're either going to affect the performance or you're going to be using too many resources. And I can promise you that doesn't matter what any provider says. You're allocating more resources, you're going to be paying more, right? Whether it's serverless, right? Whether you pay by the minute or you pay by the hour or you pay by the second. And again, the more granular we get, the more decisions you have to make in real time on what gets what in order to assure application performance. How do you match supply and demand? And the core of what we've been doing for 7 years is build this marketplace that is fully abstracted, right? I mean, we showed you a supply chain that's specific to certain entities, but these are not actually in our code. This is just to make it easier for you to find it in your infrastructure. Our algorithm just works on an entity that buys and sells anything from another entity, right? And the good thing about our marketplace is there are no malicious entities. So really it is an ideal market that drives to an equilibrium where demand matches supply. And today, it's applications, VMs, hosts, and storages. Tomorrow, it's containers or container pods or servlets or whatever it is. But there's always going to be something that's going to represent the resources that you get, and you pay for them one way or the other, whether it's CapEx or OpEx. And then there's going to be the demand coming in from your users.
But do you think you ever see a point here where you go up and instead of, meeting demand by supplying more CPU, memory, disk, I/O, whatever, you actually work a little tighter with the application side to see what is using those resources, why they're using those resources, and help to make those more efficient? I think that's kind of that next step.
Half. So yes and no, right?
Which is a very fair answer, by the way.
Yeah, we're not going to guess our way through it to say that we do it,
right.
Because that's...
So if you have an infinite loop somewhere in your code, that we won't touch. We don't go into the code, but we do look, and we showed at the previous session at the beginning, right? Recognizing that the heap is not allocated correctly, right? So when you just look at things from the view of the virtual machine, that heap is active, right? So it's going to be, this is used, whether, it's not garbage collecting for 3 hours because you just have that much heap and you need less, or whether, it's constantly garbage collecting and you're not getting the performance that you want because it doesn't have enough heap, right? So we look into heap. It's not just about CPU and memory. It's the most common metrics that we talk about, right? And it's because these are the pillars anyway at the bottom, but at the top, memory is heap. That's the type of memory you're talking about. We're talking about threads, not CPU, right? And we can look at all of these things, but even in a traditional hypervisor vCenter environment, we look at ballooning, swapping, ready queues, right? All of those sorts of things, right? Giving more CPU to a VM might mean that it's going to have higher ready queues, right? Sometimes taking resources off would increase performance, right? A little bit non-intuitive, but true, right? So we look at all of these different things, and it doesn't matter to our algorithm what it's called. It's a resource, it has a price, there are sellers that sell it. Where is the best place for me to get the resources that I need as an entity, whatever it is that I am in the actual environment? And how do I need, so think of it as a business, it buys and sells, and you're a Starbucks. Okay, and you have this long queue out the door. What do? you scale up, whether it is that you open
You're asking
another
the right
branch.
guy.
Yeah, right. Two of us right here.
If
I
you
don't-
only knew how funny that was.
And I don't
I
argue.
saw the cup right there.
And I don't mean, honestly, I'm not arguing with you. I think that you take a look at something like an AppD, which we have a lot of experience with. You have to get there in the software development cycle to make those things beneficial, right? That's not
Yes.
something I put into my environment and all of a sudden I'm getting use out of it today. There's some off-the-shelf things that work, but really it's for those people doing development. So I what I wanted you to say was that we're going halfway. We support these things that we can do that without putting in shims, without putting in layers. And I think that's probably the right way to go, especially given the market and kind of realistically where people are at today.
Yeah, and if we look at stuff that we're doing, like the SQL is the classic one, like most of our folks, SQL Exchange, you give it 24 gigs of RAM, it'll use 23.8 gigs of RAM. You give it 32 more, it'll use 31.9 more. What's actually being consumed, that's where the application layer capability is in there. And we can pull that data is there to be pulled in, and decisions are there to be made based on that actual utilization. We've only just started to see that since vSphere 6.5 is consumed memory versus active memory. And you're like, it took you that long? Like, that's cool. We could have showed you, we could have saved you some time. And so when you take it outside of VMware into the cloud, into other areas, then we already kind of got there first. But absolutely, Jason, you're right, that we're not saying that we're going to solve the AppD problem, but we can introduce you to the SEs and to some good engineers from there, and Dynatrace and all these other folks.
No, that's good. I'm curious to see how many people in this space suddenly try to pivot. $3 billion is a lot of money, right? And so
17x valuation. That's another
Exactly.
compelling reason to do some neat things.
Can you show kind of the integration to AWS or Azure, kind of what you need?
Yes,
what your
of
capabilities are?
course.
And I'm actually going to catch, because Pietro, you'd asked the classic question of like, this is great, but let me see it, like, let's grab onto a new resource, especially because we're real time, and when can we do it? So we kind of went with the Martha Stewart pre-baked oven deal here because we wanted to have live environments that have got a certain amount of data in them. And I apologize, we probably should have one that's a blank instance. We'd actually have to provision one and attach it to something, but you're absolutely right. And during the course of this, we would be able to gather data, and then the level of decisions that would be and actions that are in there would increase. But it's funny, I should have thought to have that ready to go. So I apologize, we're probably too far in to be able to get that rolling for you, but I promise you, I'll get you an NFR and you can fire it up in your own lab. And same thing, offer for all the folks that are here. We'll make sure we enable you.
Generally, how long does it take to bake up enough data to make an informed recommendation?
So as I mentioned before, most of the decisions are fully real time, right? Placement, scaling up, provisioning new hardware, things like that. The scaling down, whether it's suspending hardware or sizing VMs or containers or applications down, that we do take a little bit more. The minimum is 24 hours before we even start, but it gets a little bit more aggressive.
Gotcha.
But 30 minutes is we actually talk about 30, 30, 30. So that's my marketing hat that I got to put on for a second. It's 30% increase in application performance on 30% less infrastructure, and I can get that to you in 30 minutes. So, which is kind of funny because we just said a second ago that it takes 24 hours. So it's 30, 30, 30, 24.
Before we get to the cloud.
You can say 30 hours if you really want.
There we go. We can keep it
but
on
I'm
the
in
30s.
engineering. I'll give you the right answer.
Yeah.
You had up adding additional things to manage, like vSphere and all that. Mm-hmm. Because we're looking at credentials for a large part of our environment, how's that stored? And then is that part of the machine? Like, is there a backup configuration? Is that stored with it? So security, and then if I ever needed to restore the config, do I have to re-put in all the credentials?
So if you had to restore the config, you had to put in all the information again, because we don't, it's stored in one file. So if that file gets corrupted in any way, we don't store it in our system, and it's fully secure, it's hashed.
Okay.
And non-reversible. So that's why it's a bit of a drag that you can copy the file, but effectively,
No, it won't.
You got to kick it up from start. And you can back it up in the traditional way because we actually just deploy as a virtual instance, whether it's in AWS from the marketplace or Azure from the marketplace. You can spin it up. I'm even a goofball on my blog. I can blow one into DigitalOcean with not an Ansible. Sorry, Larry, that was a throwback to Ansible there. Terraform script. And I can fire it up in about 15 minutes. It's just running on CentOS base.
Okay.
And then you would go in and fire in the credentials from that point on. Okay. And you can actually do that through the API as well, which is pretty cool with the most recent release.
Did you go into the load balancers as what was supported?
Yes, right now out of the gate, Citrix and NetScalers are a dedicated target.
And AWS ELBs.
Right.
But
I couldn't remember if you went into that. I just was curious.
Right, but the AWS ELBs won't appear under load balancers. They're just
None of the
AWS.
none of the F5 big IPs,
Right.
any of those guys.
So we've been
It's always that fun dodge. Like we haven't
There's a
had anybody
reason you
ask.
didn't go into
Like
that,
other
right?
than
Really?
like us.
Oh no, it's just
I'm just kidding.
Like
Yeah,
intellectually,
it's not our
we should say
most
yes,
common deployment.
but we haven't had an actual active customer engagement versus we've had active customers on the Citrix
Yes.
side. We could fire one together relatively quickly, and we tend to spend the engineering in a sort of a just-in-time model. And so we have quarterly releases, and we actually have even faster than that technically with some of the micro
Yeah.
releases. So we tend to react more to customer demand, and so far,
Gotcha.
surprisingly, haven't seen it.
we
All
get a
these-
lot of questions on F5, but whenever we ask, would you actually, want to spin it up? The answer is no. Don't really use it. Okay, or something like, yeah, no, I get, so that's why we haven't really.
Yeah, but you could do some really cool stuff.
Sorry.
Yeah,
Mike,
I have a question
Oh, yeah, that's where-
about these
yeah.
connectors, or how do you want to call them?
F5 takes care of a lot of them.
Do they come natively out of the box with the product? Do you upgrade them with products upgrade? Is there a marketplace where people can add additional plugins or connectors? How do you manage this?
So it comes fully packaged with the product. We do have an SDK out there, so you can develop your own if you want. There isn't yet a marketplace for that, but as we grow and scale, hopefully we get to the point where yes, there is one. But if you wanted to build your own integration, there's an SDK, there's documentation. You could just do that, and you'll see that come right up.
But when you develop a new plugin, I don't know how you call it, a connector that manages another, I don't know, like you mentioned, set of makeover of load balancer or anything like that. Do you include it in next releases or in upgrades, or do
Yes.
you have a way to download it and load it in an existing installation of your?
You have to update, but the update process is very simple. You'd go right here. You'd go to updates. You could check to see if there are any updates.
And the reason is because
aren't
if it's a
any.
new entity that we're attaching to, it has to be mapped against the market model so that we understand how to relate it.
Okay.
So it's not just the connector itself that's going to be added, but there may be another into the abstraction layer in order to make sure that it maps
So
against
they
the
are not
market.
treated as plugins; they are treated as an integral part of the product.
Correct. Yes.
Integrations.
Yeah. Yeah.
Yes.
There's the only difference is that some are unlocked with licenses. So there are some like out if you get the default, then there are some tiers. Like we have a cloud native license, we have a traditional license, we have an application level license, and there's a few different ways that we can attack that depending on what your requirements are. And that's sort of a continually revisited thing because most people would say like, why would I want cloud and in Java application layer when I'm only running a 12-host environment on-prem and it's running Exchange. So there's a few different ways but that's not exciting to the folks on the live stream. Hi there, I know you get tired of licensing, so let's okay.
Okay, so I've been asked about cloud. So let's start talking about that a little bit.
You have to do jazz hands when you
Cloud. So yeah, that is the big word. I think what was interesting to me when we started developing this is that our algorithm works on a market model, and we abstract cost to represent demand and supply of resources for before we even started integrating with cloud. So now the question was, how do we integrate with real cost, right, with real dollars, and have that drive value for our customers? It was a very natural integration for us and an extension of our offering. Now there are different ways to think about hybrid cloud environments and multi-cloud environments, and we can talk about all of that. And I don't remember who asked about merging data centers before, but the same with hybrid cloud environments. When you think about a data center, for us, for our abstraction, we force these boundaries on our market because we know that's what our customers want. But for us, that's something that we input to restrict the value that we can bring, right? So as we open up data centers, if that's relevant, we do that a lot with customers with clusters, right? How do you merge clusters? How do you integrate them to really open up the boundaries and see what you really could get out of the hardware, right? The more constraints you add, the less efficiency we can help you drive in the environment. And with hybrid and multi-cloud environments, the same is true. We'll have some customers that would say, we want to treat our hybrid cloud environment as a single pool of resources, and you tell me what needs to run where and when, and scale out to the cloud based on demand and come back. We'll have other customers that tell us, no, look, we have certain workloads that really work well on AWS. They use certain services. They use, they use S3 and they use Lambda, and they integrate with certain services. That's where these workloads need to live. It doesn't matter whether I can fit them on-prem or not. And then, maybe I have other Exchange or O365 workloads that really need to live in Azure, right? Because that's where they thrive best, right? And it doesn't really matter what costs what where or how demand shifts that. This is the prerequisites for those applications. And with Turbo, we can manage all of these complexities and differences, right? We look at the environment with the constraints that you bring to us, and we open them up as much as you let us, but we look at all of those. So by default, when you look at our product, we won't tell you to move from AWS to Azure, or from Azure to on-prem, or from on-prem to AWS. We let you tell us how much of that you want to open up. So what do we have here? We have here an on-prem environment connected to vCenter. We have AWS, and we have Azure.
Yeah, Canada East. That's right.
Woo. So this is a multi-cloud environment, and kind of the first things that you're going to see, and again, this is fully configurable, so the views change is going to be what we call the expense versus budget. How much is it that I'm spending across all of my cloud environments, right? So this would be across AWS and Azure.
I thought that said 100 million. I was.
Ooh, no.
That's the kind of savings we can bring you with Turbonomic. That's right.
I wish.
You could buy AppD next week.
A couple of them.
I'd get a pretty big bonus if
That's
I could buy that. Okay, so this just tracks the overall expense, right? You can track it. This is currently, I think, a daily view, but we can track it, again, on a weekly or monthly basis. And then we aggregate that to what does that mean for your monthly bill? What does that mean for your yearly bill as it is now? And then most importantly, just as we do in everything else in our UI, everything after that green line is where we could get you with our actions, right? So we could bring you to a point where you pay less. We also let you define that budget, the capacity of your money in the cloud, right? And visualize to you when it is that you're above that and whether there are things you could do to be below it, right? That a question?
Yeah.
Okay.
John's just thinking, what about private clouds? What about private clouds?
I will
Holding
ask
that
a question.
hope.
One thing that's been kind of jumping around in my head is like, who's your target user for this software? Because there's some operational stuff, there's some business side stuff. You definitely can't have usually a tier 1, tier 2 person probably operating this. So who's in your success stories, who's that actual ideal user for you?
It's funny, I thought that with cloud it's going to change, but even that is coming back to IT, it seems like.
But who?
Right. So anyone from the CIO down to the system admin who really needs to integrate with it. And we try to build it in a way where it's really helpful to those that interact with the environment to help them assure performance of applications much in an easier way, to be able to drill down when they need to, but most importantly, just log in and see what the state of the environment is. But also create views that are a much higher level, that are look at this environment in a more, let's look what happened last year, throughout this year, what actions have been taken, what were my risks, what is the performance of the applications throughout that, so more aggregated views, right, that are more for higher level up to CIOs. Things like how much more efficient am I running my environment now compared to a year ago?
It's definitely
Things
the
like that.
operations audience is the most common one because they, given the roots in enterprise data center, like we tended to look at it as the ops focus of like infrastructure up, application down. Even when we look at application down, we're usually talking to the infrastructure owner, and then we get a little bit, as we get into the actual legitimate budgeting, then it starts to move a little bit further up and they start to pass over. I mean, because we know the CFO is kind of saying, hey, you're not just buying stuff every 5 years and amortizing, I'm getting this bill every month. And so we're seeing a switch in who's watching what we're doing, but we're definitely, like I said, operations focused and starting to swing into the budget owner because of especially the cloud story.
Do you monitor how much time people spend inside of the system and where?
Oh, like to keep track, like a time card style, just to know.
I mean, it's like doing
Yeah.
web tracking. I mean, what page is the hot one? Which, how much time are the average user spending inside of the system per day, per week, per month?
So for security purposes, we don't communicate from our instance installed at a customer environment back home anything today.
Why not? Almost everybody else does. There's not a storage vendor out there that doesn't.
Yeah, it is a good point.
Yeah.
We-
Is that a Vizio?
yeah.
That's a Samsung. Vizio's the one that.
Yeah, we don't do that today.
Yeah.
When we do interaction stuff, we do customer interviews and we do a lot of more like
Yeah.
on-site stuff, but we're not continuously gathering that information. It's a good thought. And in fact, if you want to get hired in our customer experience area, like that's kind of a big thing. It's pretty cool because.
Walk over now.
Yeah, that's right. I think you may know them. So the good thing is, we see that's where it's going, and it's a great point. But we don't do that today. For right now, it's more, what are they feeding back to us? And it's a people process right now, which is kind of funny that we're in the world of automation, but there's still a lot more people stuff. And even the trust factor with automation, especially when we get into
Yeah.
cloud sizing, then we're talking to developers and application owners now, and they're a bit more of an adventure to work with because they come out of a very different style of how they think about performance.
Does this let you, when you are bringing new workloads into the environment, does this give you the ability to sort of forecast, like, I know I'm going to have 10 new VMs with this starting out at this size? Does it give you any insight into, you should put this in Azure, AWS, or run it on site?
It's like you wrote our plan for us. This is great.
So right there at the top right, there's I don't know. The scale is
Sorry, it blew off the
cut
screen
off.
a little bit.
Yes, but it says plan, right? What that means is we take the market, the algorithm that we work on, we copy it, and then we allow you to modify it in any shape or form that you want. You can add demand, you can change supply, you can add supply, subtract supply, replace it with different blades with different storages and see what happens, right? So for example, one of the very common scenarios for us is a hardware refresh, right? So you can say, I want to take, this cluster, and what happens if I want to retire this? How much from this new hardware should I buy, right? And we can help with this decision-making process. So first, right, it's like, let's plan the changes that I want to make, right? So which hosts do I want to change, right? And we can select those, right? Which ones do I want to replace? Let's say I want to replace these two. Click replace. And then I could, from templates in my environment, I could either replace it with a template that I set or with something else that I already have and own, right? So let's just take this as an example, right? And then I can run it. I can also continue to change on top of this. So I can say, okay, what happens now also if I add, a few more VMs, or if I add more hardware, or, things like that. Or what happens if I ignore constraints in my system. I want to, let's take, for the scope that I'm in, I want to ignore cluster constraints or things like that, right? And then I can scope it. Let's just choose one cluster. But let's just run it as a whole. And then I can run it, and it tells us exactly what it is that you'll need to do. We'll get back to that in a second. Here is historical list of all the plans that have been running. This was the reconfigure hardware that we just ran. But there's everything that I do gets tracked, and I can go back and revisit those results.
There's also a reservation capability. So you say, like, look, I've got a SharePoint environment that I'm going to put up as an example. So I know it's like 7 servers. I can model it after a farm that I've got today. So I can create a reservation for it. And what it's doing is it's marking that spot, and it's creating these sort of like shadowed servers that are there. So when we make any other decisions from that point, so I know on July 13th, I'm going to get this approval to put it in there. So I put it in there in my system. So all of the actions that are being presented to us now from this point until we actually deploy are done with the context that that virtual load is coming. And it's obviously it's templated, because of that's not real time yet, but you do have the capability. And you can also say that when you want to do a deployment, it'll say, all right, you should put it on this host this way, in the same way that we know the old school DRS method of like, I'm going to put this in there. If you set it to manual, it'll say which you should put it here, but here's 4 other places you can put it. So we'll give that same ability to make that first decision, except it's made in the context of the complete performance picture. And we may even go, is this the right cluster to put it in? If you think of it at whatever the context level you want, so we can both do the active deployment or create reservations in advance.
So here's an example. I just randomly picked 3 VMs in my environment and added 10 instances of each of them, right? And this is adding them right now, but I can schedule and say, let's add this now and then add the same amount every month. And let's see how that plans out, right? So maybe if I continue growing at this rate, this month I'm fine, next month I'm fine, the month after that, and then it allows you to plan and project forward. Then again, I click run. Once it finishes running, we'll get the results and see what's going on. And takes a few minutes.
And as Mor mentioned, this is the same engine. So when we actually run these plans, it's not just like taking it and doing a linear growth. It's actually simulating the entirety of the load in so as if the real-time engine was running, but it's a copy of it so that it's not negatively affecting the actual real-time environment, which is it's kind of cool. Way more cool to me than it is probably to most people that are watching, but it's helpful for us, especially because we want to look at when you get very active environments and they do a lot more capacity management through the platform. You've got different teams that are doing it, and you may have 12 different people that are doing things in Turbo at the same time. So we want to make sure that we scale the way we do things in order to meet that requirement. Everybody's smiling over here, so I know you're all writing something on Twitter that I didn't see yet. So, I'm coming after you.
So question, is this all a cloud-based application, or is there a infrastructure to maintain for this environment?
We deploy on-prem as a traditional, like a VMDK or like just out of an OVF, or some NASA VMDK. Derp. So yeah, it's an OVF that we deploy, or we can deploy as a VDI. And then in the cloud, we just pull right from the marketplace, whether it's Azure or AWS.
Cool.
And then we can actually we support a full build, so you can just drop a CentOS machine in or a Rev machine or a RHEL machine, and we have a deployment script that'll run us on top of places. That's actually, and that came as a requirement because some of the customers, they were like hardcore, Red Hat shops, and we were using OpenSUSE before, which is, probably was the most common one that we saw in the field. And so we had to shift away from that to meet their requirements. So we said, all right, let's learn how to do it, basically build from source. So that's kind of where you can see things are going, especially as people get into containerized deployments. So if there are applications where you could much more agilely, whatever the word is for that, drop it into the environment.
Agilely.
That's Italian.
Agilely.
So how do you pull metrics for like workload metrics from AWS or Azure? Do you pull workload metrics?
We do. Let's get a little bit into that. But before we look at okay, so we covered this is a hybrid environment. You see the overall expense in your environment, but what's interesting is when you talk about the actions and the output and how we capture the outcome of those. And what you'll see at the top right there is that we separate between those actions that have one-time savings associated with them, those that are amortized, right? Those would be the on-prem outcomes, and then the cloud ones that are monthly, right? So in this environment, overall, we see that you can really drive higher efficiencies out of your cloud platform that would be worth just over $1,000 a month. What we have here is we've also configured a cloud migration scenario. So in order to accommodate that extra workload, and I'll go into all of that exactly, but accommodate the extra workload plus assure the performance of those applications, you need 2.5 more, right? So that would be more workload and some scale up that is required. This instance is cloud environment, and you'll see that we don't have an on-prem savings here, right? There's this is it's still a hybrid cloud environment, but the on-prem footprint is much smaller. There's no savings there. And let's look into what we have here. So you'll see sizing up and down of workloads, right? All of the actually, let's start with just looking at what it is that we have here, right? This is a list of VMs in the system. All the ones that have a cost associated with them, those would be the one running in the cloud. This is how much you're paying for them, and again, the actions associated with them.
Do you pull that pricing data?
Yes, we do.
Okay. Do you know if I'm doing like reserved instances or spot pricing or something like that?
Today, no, we don't look into that. We just look at the entity, the on-demand price associated with it, and the resource consumption.
The price for that.
Yes.
The published price based on your contract as well. You use your credentials, so if you have a contracted deal with AWS, we're using your credentials to gather the pricing API. So if you've got a list discount baked in, your detail will be different than what mine would be because I'm running my homegrown.
But it is in our roadmap to make this.
And on a tangent, do you also monitor like S3 or Glacier consumption and pricing as well and show that?
You keep tuned to our secret session after we close the monitors.
Today we do not have that. That's
Okay.
what you could say. Yeah.
But a great question. Thank you. So again, a list of VMs, you'll have some of those on-prem that don't have an hourly cost associated with them versus those that are running in the cloud. And let's go back to the actions, and easier to understand right now what those would be. Let's look at the sizing. Okay, so there will be actions that require an investment. Those would be the scale up. In this case, increasing a CPU for an AWS VM to go from its current M4 large to an M3 extra large to match the demand, and it requires an investment of 24 cents. Sometimes we have to invest in our environment to assure application performance. But sometimes we can save by squeezing the most out of our environment. In this case, reducing CPU by moving from an M3 extra large to an R4 large.
And because of the
Fairly
different,
simple.
if anybody's gone through the EC2 instance types and the like 17 pages of scrolling you got to do for the different types, we've got that differentiation there. So this way you don't have to do the guesswork on what it is, because we're seeing that in advance for you. So those decisions based on actual consumption is baked into the action we provide.
Right, and now if we go back to this instance, let's look at the placement actions.
The bonus about this as well for the folks that are especially dabbling in new cloud exploration is I would bet you that you're going to do one of two things. One, you're going to do everything wrong and deploy it all in the US East 1, which is the default if you're in AWS. And the second one is you're going to get smart and you're going to deploy it to a couple places. I put a couple in Ohio because I'm a big supporter. Stephen is my friend. I'm going to put some business in his state. So I put a few in Ohio, and Tim as well, of course. And then I forget where are all my machines. I know I forget. I'm sorry to my wife. I got a $600 AWS bill last month because I forgot that I left a whole bunch of machines running in Ohio. You're welcome, Ohio. But 600 of my money went into that. And then I went into, of course, my Turbo instance, which I should have done to start with. And it shows me the total view of the entire AWS infrastructure. But if you go into AWS, you have to literally drill in region by region, and be able to find that. So we give the holistic view, including what your cloud footprint is. Yeah, that's right.
Seattle thinks you should
I
be
got
running
screwed with
to
that.
That's right, exactly.
So part of, as I mentioned, we, by default, we look at the constraints in the environment and we respect them. But if you let us do a little bit more, like say, don't keep my VMs in the region that they're currently at. I don't need to use just Ohio. All of the US is fine for me, or all the East Coast is fine for me, or just keep me on the West Coast for those Seattle folks in the room, right? Anything you do, and once you open up those boundaries, we start looking at, for the instance, as it's currently configured, where would you pay the least for that instance across whatever it is you open up? It could be multiple, AWS and Azure, combine them, I don't care. Or, US East 1 and US East 2, those are fine for me, right? And as you do that, we'll find for, again, in real time, the right placement, now from a cloud perspective, the right placement for a workload at the right time and how much you could save by executing that action. Good.
We always get
I always
worried
like
when everybody
that.
goes quiet. I check Twitter. Okay, yeah, no, they're not killing us online. All right, they're actually legitimately taking it all in.
No, what's interesting to me is we started talking a little bit about how you can configure your business rules into Turbonomic, right? Eric started talking about compliance. What's interesting with the cloud is that a lot of people think it's a plug and play, right? I mean, they just do everything for me, right? And I'll just put everything in one region, or I'll split it out, or I'll forget I have instances running. That's one thing that's really important to understand specifically about AWS, right? You have multiple availability zones on each region, and then you have multiple regions. But, S3 crashed a few months ago in US East. Happened, right? And I basically have a friend who's running R&D for a certain startup, and they lost a lot of business because they're using S3 and their application is based on that, right? But then, so I asked them, why aren't you using multiple regions? It is the same AWS environment. It should be relatively easy for you guys to just, it's a fully horizontally scalable, stateless application, right? They're a startup. They've just recently wrote their applications, so they're up to speed. Why not? And he said, it's just too complicated, right? And then I have to manage 2 environments. I forget what I have where. It's not intuitive. But the thing is, when you just choose one region, then that there's a risk associated with that decision. But even if you're just running on one region and you decide to go with that, when you launch VMs into AWS, they kind of randomly pick availability zones. But the thing is that the uptime guaranteed by AWS is only guaranteed if you're using multiple availability zones, right? So how do you then need to look into all the applications that you have, and for each type of application, make sure it's running on multiple availability zones at any point in time? Because there really is, the region crash where S3 crashes across an entire region, fairly rare. I claim you should still be ready for that, but even if you decide to only use one region, you really have to look at those availability zones. With Turbo, we add those just like we do on-prem for licensing, as we mentioned, or other constraints that you might have. We can do that for exactly this. For each type of application that you can define, right, spread it on all of these hosts, right? And then we'll have certain move actions between availability zones based on that compliance.
Maybe before because I know we're rounding up to the finish here. We got a couple more minutes left. Do we have a second to rip? I say a second, just a small little thing, containers. I know, Larry, you'd asked about containers. We'll do a quick view of it, and obviously I wish we could spend a little bit more time. We covered a lot of ground. I hope that we've kind of touched on some interesting things. Definitely there's more to discover, and we'll get into things offline. We can talk a bit more deeper on stuff, and hopefully for all the folks on home, hi everybody, we'll have more. So we'll just take a couple more minutes, and then I know Stephen's gonna be ready to walk us out, and then we're gonna have some lunch goodness, and we will assure lunch performance while maintaining your efficiency.
That's the container I need. Food.
Anything else we wanted? Containers?
Yeah, do we have a container instance?
Yeah, I'd really like to see a lot more
Well
of that.
played. Office space.
So with containers, I think one of the interesting things is if you look at containers, most of the time running on VMs, I know running on bare metal is interesting, but to be honest, what we mostly see is containers running on VMs, especially when we tie that back into cloud, right? And a lot of the problems relevant for that are actually this, if you think about it, it's very similar problems to VMs running on hosts, right? How do you pack them efficiently to use what you have? How do you scale? And then when do you scale up, or when do you scale out? When do you size things back down? How do you place them so that they don't compete on resources? So you don't build up contention in a certain VM for the same resource, right? And then these things change dynamically. With containers even more, right? Things change even quicker. So it's harder to keep track. And now instead of having, a 10 to 1, 15 to 1, 20 to 1 ratio, you have 100 to 1, right? It's just all bigger scale. It's harder to track. Sprawl is, I think, going to become a bigger problem with containers than it is for VMs. We're just starting to scratch the surface, especially larger organizations. But I think sprawl is going to be a very big issue with containers, keeping track of everything you have, where it's placed, and when it's actually being used. So the same problems that we solve for VMs are the same. These are the same problems that we solve for containers. Okay, so let's look at the containers, right? And we'll see.
We're kind of hitting two of them right here because we're actually pointing to a Cloud Foundry environment, which Cloud Foundry, of course, runs as a containerized sublayer. So it's interesting that we actually, as we had to attack the problem of PaaS, and as we know, there was that little company about 4 years ago that was building a PaaS environment, that little company called .cloud, and then they had to build Docker to run the PaaS, and then that kind of turned out to be a thing. So that's why we had to solve both of those layers at the same time.
So again, when we look at the container, we look at it in the context of the application and the infrastructure that it's running on, whether it's on-prem or in the cloud, and then identify when we need to scale it either up or out. In this case, adding vMem, because there's vMem congestion on that application. We can go back to the list of, I need to look at it.
And you can see sort of in containerized environments, the depth of the number. There's a throw out to Nick, because I know he's like, why, you got a lot of decimals in there? But like the way that we do our containers,
Nick doesn't like decimals.
I need 108,134 kilobytes of RAM. But at the containers, the moves are going to be much more smaller. And because we don't use thresholds, we legitimately look at what's going to solve the application problem. We're not just saying you need to have 50% overhead. So if you go to 51, then double the amount you're using right now. We are actually looking at what the true consumption was and then deploying. And the classic one, while bin packing is kind of neat in how they're solving it in the traditional schedulers today, I always say we have 110 reasons why Kubernetes needs us. And I'm not going to go through all of them, but let me tell you, there's only really one. Because the maximum number of schedulable pods you can have on one Kubernetes node is 110. Why? It's an arbitrary number that was chosen because we figure that's kind of the right number. But is 109 too much? Is 48 the right much? So where we plug in is to be able to make sure that while you hit that top arbitrary limit of 110, that the ones that are there are truly the right ones and that the scaling infrastructure is done right. So there's a lot of ways. It's a real much deeper conversation. We could do we'll have Tech Field Day back another time to go 2 hours just raw on containers and cloud.
So are you talking scaling the containers themselves or scaling the hosts that are providing the Docker engine and things like that? Or both?
Everything,
Okay.
right? We look at the application. We look how that consumption coming in from the application affects the container, affects the VM, affects the hosts, affects the storage, right? So when we looked at the heap example before, right? When we need to increase heap. When you just look at the application out of context, then in this case, increasing the heap was the answer, but is it? Or is it just not getting the memory that it needs from the VM because the VM is congested on memory, right? It doesn't have enough. Or it's running on a host that has another VM that's hogging all the memory, right? There could be a lot of reasons, right? So we look at everything in the full context of the supply chain, right? Take a look, virtual applications are what you would call load balancers. What are the transactions coming into the application, right? How many requests are hitting it? Right, so we can understand when it needs to scale out, right? How many transactions are hitting it? How does those resources, the heap, the threads, connection times, all of those things that we talked about, the application layer, how do they affect the containers, right? How do those containers affect the VMs, right? You've got to understand everything in this.
Because this is where the load balancing thing comes into play, right? I mean, as transactions
Yes.
increase or service discovery or anything like that.
Exactly.
If you can tie into those things, that's
And we move
Also-
because we move beyond the container to the pods. We can say you need to scale the pod number. So it's the scaling styles change,
Exactly.
but the concepts that drive the action are, and the decision level is what's interesting. So we take that same abstraction. So the beauty part is all these other products are trying to attack some of these problems, and they've got a sort of a one-point view on it, which is great. Like that's very specific and very solvable in that one area. But we've had the same engine since the start of the company, and we
Yeah.
just we take that same abstraction layer and then just move it into whatever context we need to, which is pretty cool.
There's one point that Eric made that reminded me of something in the context of cloud, if we go back 3 minutes on time. When we talk about scaling VMs in the cloud, right, or whatever it is, because we're not threshold based, right, we don't look at, oh, you chose this family type, and because you crossed, we now double everything, because everything is bundled together, right? Because we really look at the demand and match it to the supply, we're able to do cross-family type and instance type scaling to really find the right ratio between memory, CPU, I/O, and network, which are the only kind of things that those templates in the cloud allow you to play around with. But we look at all those four together to look at in real time what is the right template for the right workload at the right time.